Yo, yo, it's your boy Mr. B in the house bringing you some maths. Now check this out. Find the exact value of sine of 60. I know you're thinking, you're like, yo, Mr. Borges, that's easy, ain't it? I'm just gonna get my calculator, I'm gonna put sine 60 and it's gonna give me the value. What are you on about? Well, I wish it was like that, but the people making your GCSE think it's 1965 and that you should know how to do this without a calculator. So, let's learn how to do that without a calculator. So what do? First thing you need to do is, and this is a hassle, just letting you know, you're going to have to build up a table. The table is always going to be the same. You're going to start with sine and cos. Those are going to be your two columns. Your rows are going to be 5 angles, and it's always the same 5 angles. 0, 30, 45, 60, and 90. Cool? So those are your rows or your columns. It has to be always like this. If you switch anything around, you're gonna get everything wrong. You got your rows and your columns, what do you do now? You're gonna go 0, 1, 2, 3, 4, 4, 3, 2, 1, 0. Always like this. If you set up your table properly, now things are easy, because look, this is how it works. To find the exact value of a sine and cos, you're going to do square roots of whichever numbers on the table divided by 2. Always, 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 always. So let's look at an example. Find the exact value for sine of 60. Alright, let's take a look. We're going to do a square root of which number is on sine 60? It's the number 3. So it's going to be square root of 3 divided by 2. And you're done. Let's take a look at another one. What would be cos of 0? Alright, let's take a look. We go to square root of whichever number is on cos 0, that's 4, divided by 2. Square root of 4 is 2, 2 divided by 2 is 1. And you're done. Easy peasy. Alright, you give it a go. Find the exact value of cos 45. Pause here, come back when you got an answer. You should get root 2 over 2. One more. Pause here, come back with an answer. It's a half. Last one, pause, come back with an answer. 1 over 2. Alright, let's make things a little bit harder. Find the exact value of tan of 60. What do we do? The table only had sine and cos. Now, don't worry about it. Look, we're going to go back to our table. The exact value for tan is going to be square root of whichever numbers on the sine row divided by the square root of whichever numbers on the cos row. So square root of whichever numbers on sine divided by square root of whichever numbers on cos. So let's see how this works. If I want to find tan of 30, I'm going to do square root of which number is on sine of 30? That's 1. Divided by which square root of whichever number is on cos of 30, so that's going to be 3. Cool. Now, I can't leave it like this, so I need to simplify a little bit. First, this is going to become square root of 1 is 1, so 1 over root 3. Then I need to simplify more, so I need to rationalize this. If you don't remember how to rationalize, go and check out my video on surds or sort your life out. I'm not going to teach you here. But once you rationalize this, what do you get? You get root 3 over 3 and you're done. Easy peasy? Alright, you give it a go. Find the exact value of tan 45. Pause and come back with an answer. Tan 45 is 1. One more, find the exact value of tan 60. Cool, you should get root 3. And final one, find the exact value of tan 90. Tan 90 should be undefined. That was a tricky one. Why is it undefined? Because you end up having to divide by 0. So tan 90 is actually not a thing. Tricked you there. Cool. Now take a look at this question. Check this out. Work out sine 45 plus tan of 60. Now this question looks like a trig question, but actually this is a surds question. This is a simplifying, adding and subtracting surds masked as a trig question. Because the trig part ends in like 30 seconds. You do the table, you find the values. You find that sine 45 is root 2 over 2. Tan 60 is root 3. And the trig part is over. Now it's just surds. So we're going to do root 2 over 2 plus root 3. Get them in the same denominator. You're going to get root 2 over 2 plus 2 root 3 over 2. You got them in the same denominator. Get them in the same fraction. Root 2 plus 2 root 3 over 2. Easy peasy. Could you have simplified here? Not on this one, but sometimes you'll be able to. So be careful. You're going to have to simplify as much as possible. Ready? Give it a go. Work out this one. Pause here. Come back with an answer. Should get 3 over 2. One more. Pause here. Come back with an answer. Should be 1 plus root 3 over 2. Final one. Pause here. Come back with an answer. Should be 5 root 3 over 6. Got it? Right, let's go back to some actual trig then. Take a look at this example. On triangle ABC, work out the value of AB. Without a calculator, obviously. Alright, so what do we do here? So our main man angle is the angle B. So we're trying to find hypotenuse and we have the value of the opposite. So if we have opposite and we're trying to find hypotenuse, we're going to be using SAW. Do not rearrange formula here, just use the formula triangle. So we're trying to find the hypotenuse, so we're going to start our formula with hypotenuse. So we're going to say the hypotenuse is going to be O over sine. Cool, we can substitute stuff here. We're going to get the AB is equal to 10 over sine 60. This is when the non-calc trig came by. What do we do now? We go back to our table and you see the sine 60 is root 3 over 2. Yeah? Now it's going to get a little bit fiddly, so please pay attention. So if sine 60 is root 3 over 2 and AB is 10 divided by sine 60, you're going to get the AB is equal to 10 divided by root 3 divided by 2. Do not freak out with a fraction like this. What you need to remember is if you're dividing by a fraction, what do? You're going to keep change flip. So the division is going to become a multiplication. Root 3 over 2 is going to become 2 over root 3. Got it? From here is easy. You're going to get the AB is 20 over root 3. Rationalize this. You're going to get AB is 20 root 3 over 3. And you're done. You leave it like that. Got it? Copied everything down? Alright. You give it a go. Find the value of BC. Cool. You should get 3 root 2. One more. Find the value of AC. You should get 5 root 3 over 3. Last one, find the value of AB. Cool. Should be 6 root 3. Got it? Last type of question now. So we found the sides. What do you think is going to come up? You got it. We're going to have to find an angle. So on triangle ABC, work out the value of A. Cool. This is a little bit more fiddly, but not a big deal either. So first of all, our main man is angle A. So we have adjacent and hypotenuse. If we are dealing with adjacent and hypotenuse, we're going to be using K. We're trying to find angle A, so we're going to start our equation with cos. So cos of A is going to be adjacent over hypotenuse. Substitute. So cos A is going to be root 6 over 2 root 2. Let's simplify that a little bit. So we're going to rationalize. So we're going to times top and bottom by root 2 over 2, which is going to give us cos A equals root 12 over 2 times 2. Mr. Burgess, why is it 2 times 2? Because root 2 times root 2 is 2. Cool? Now slowly. The denominator, 2 times 2, is 4. Hope you got that. Now the numerator, root 12, we can actually simplify this. Again, if you don't remember how to simplify a surd, go back to surds. Do some revision, sort your life out, but it should give you 2 root 3. We can actually clean this up a little bit. We can simplify the fraction, divide top and bottom by 2, and you're going to get cos A equal root 3 over 2. And some of you will stop here and say like, done. But the question is not asking you for cos of A. The question is asking you for the value of A. So what do we do now? We're going to reverse engineer. We're going to go to our table with a cos, and we're going to see which angle does it give us. Now, we're looking at cos, yeah? So we're looking at the second row. So what we're going to see is which angle on the second row has the value 3. Why is it 3? Because it's root 3. And remember, it's root of the angle of whatever number is there. So which one has 30 degrees? 30 degrees has the number 3. So we know that A has to be 30 degrees. Cool? Copied everything down, made some notes. It might be useful for you to go back on the video, like copy the next question, go back on the video, and try to work out step by step like I did. If not, just go crazy. Do you. Right, triangle ABC, work out the value of C. Should have gotten 45 degrees. One more. Triangle ABC, work out the value of B. Should be 30 degrees. Last one. On triangle ABC, work out the value of C. Should give you 60 degrees. Alright, let's take a look at recap time. Let's take a look at what we learned today. So first thing that we learned, in order to build your table, the rows are going to be sine and cos. The columns are going to be the 5 angles that we need to know, 0, 30, 45, 60, and 90. To build up your table, you go 0, 1, 2, 3, 4, 4, 3, 2, 1, 0. And the exact value of sine and cos of any of those angles is going to be square root of whichever number is on the table divided by 2. If we're trying to find tan, what is going to happen? I'm going to do a square root of whichever value is on the sim column divided by whichever value is on the cos column. If I'm trying to find a side using exact values, what do? I'm going to use SOHCAHTOA to set up my equation. Remember to use the formula triangles, don't rearrange stuff. I'm going to use the table to find the value of cos and sine and substitute it into my equation. And I'm going to simplify as much as possible. Simplify your surds. Cool? What about if I'm trying to find an angle? I'm going to use SOHCAHTOA. I'm going to simplify the expression I get as much as possible. And then I'm going to go to the table and match my sine and cos to an angle. Easy peasy. Alright, hope that was useful. Hope you understood everything. That's it from me. Borges out.